38. And I told you there is no tables unless I give you, of course, numbers, and you have to come up with the logarithmic doing the regression, but you don't have to come up with your own table. The equation that models the time required to reach a particular radiation level after a radioactive leak is given by this equation, where T is the time in years. I'll put this down like this: years, and I is the target radiation intensity to be reached. Okay, so this is the target radiation. Sorry, I'm mixing this up, right? Mr. Dirksen. What's the x variable here? This is your x variable. So this is radiation. And time. So this is the weird part, that time is in your y variable. That is the weird part about logs, okay? So I will say that note time is our y variable. Watch out for that. Don't let that throw you off. It's like that. I told you that when we do logs, we almost turn the graph sideways, and you're turning you're flipping the x and the y variables in a sense. Okay. The initial radiation intensity after the leak is estimated to be this much per year. Okay. There's an initial radiation intensity. It's very important. So what does that mean? Initial radiation intensity. When time is zero, we will have 1600, I don't know, millisieverts per year. I don't know. I just copy pasted that. Sorry guys. I've never seen that. Make a graph of the time required as a function of radiation target. So we're going to enter that into our calculators like so. So go ahead and do that because you need to be okay with Windows. And it's natural log. Make sure you don't mix that up because your answer will be different if you go log or natural log. So just go exactly by what it says there. And I can tell that this is going to be a decreasing function, correct? Because the b value is negative. So, and remember, 1 266 is going to be on there. Okay, so let's see, 1 266.44 is a reference, right? Reference point from equation. So I'm going to change my window. This is going to be overkill, right? It's going to be way too big. So my Y max, I'm going to go, I don't know, 500 for now. Because 1 266, so if I double that, that's about right. And what should be my X max? Probably 1600, right? Or more. I'll go more than that. Let's hit graph. And there it is. Remember, these graphs do have x-intercepts. They do not have y-intercepts. And so we're going to make this graph, recreate it as best as we can. Okay? So grab a ruler or something. So A here. Oh yeah, we're good time. Okay, so we've got to get this right. Radiation intensity. So just go by in MSV year, right? So just put those units exactly like the problem gives them to you. Just put them down. This was courtesy, by the way. The 1600 is a courtesy, right? It didn't have to do that, but. And this would be time. So this is the weird part. I should have warned you yesterday, but we didn't do word problems, right? So time in years. That is what throws a lot of students off. They think time is here. Yeah. Just a straight line. So let's look at our window. What's your X max? I'm just curious. And what about your, sorry, your X max is 1,600? And your Y max? And when you graph it, it doesn't. Go to Y equals once and just make sure you enter that your equation matches. It matches. It's just a straight line. Oh. Oh, graph it. Graph it. Okay. Right, that's good. Okay, you got that figured out? Why is he running? I don't know. I like running. So let's see, it never touches the y-axis, correct? So we're gonna make sure that doesn't happen. So I need to make sure I fit in 1600 here. So how are we gonna make that work? I think I can go 250, 500. Is that gonna work? Hold on. So this is 500, 1000. Oh yeah, it's gonna work. So I go 500 here, 1000. This is 1500. And so this would be 1750 right there. So that's what I chose. Right? Just make it fit. And then here, how high am I going to go up here? It's not smart to go exactly 266, right? Like go a little bit higher. I'm going to go 100, 200, 300, 400, 500. I'm just going to make sure there's enough room because this thing keeps on going up indefinitely. So I'm going to say 1 is right about 266 is right about there. And I know that another point is 1600. Oops, sorry, that's not right. This is 1750 here. So 1600 is more likely to be here. It actually touches, right? It actually touches the x-axis. Okay to do that. And let's find one more, shall we? I'm going to find something. What do you think? In the 500? X500, see what the y is. So we're going to go second trace 1. I'm going to type in 500 and I'm at 40. You know what? I'm going to go smaller. Second trace 1, 3, you know what? 250. Why 250? Because I have a 250 mark right there. So I'm just going to go with it. Oops. And so that's 65, 68. So 250 gets me to 65, 68. Hold it just to make sure I don't lose marks. I'm going to go second, trace 1, x is equal to 250, y is equal to 65.68. This is another reference point, right? So I basically just found this point to help me graph it. So if you have 3 points, I'm happy, okay? And you just come down from up here, never touching, you curve, and then you slowly make your way to that x-intercept. And that's where your artistic side comes in. So the arrowhead, If the arrow, by making the arrowhead touches, no big deal, right? But as long as the line, and I will have a magnifying glass, right? And I'll make sure it won't touch, right? And here it is. (3636) natural log of the intensity. And it makes sense, right? As time, right? As time gets higher and higher, the intensity actually gets lower, right? Think about it this way: the intensity gets lower and lower as time goes by, right? So it's kind of like an inverse. It's kind of harder to wrap your head around it, but this is what it is, okay? B. So we figured out our, you know what, I'm going to do B underneath here. B. What is the exact initial radiation level according to the equation? Oh, I should have figured out exactly. Okay. So we're going to go y2 is equal to 0. And here you have to be careful to make sure you extend your window enough for it to find it. Okay. So I'm going to hit graph. I think it's going to find it. Second trace 5. Enter, enter, enter. And it is actually It is actually 1522.08. 1522.08. So we're going to go 1522.08. 0 is what we found, right? So initial intensity is 1522.08 MSV. There you go. This looks like a 7 here, guys. Make sure you know it's a 2. It's a 2 here. 1. So our graph, we're going to leave our graph, okay? We're not going to touch it. It's okay. We should have found the exact x-intercept. It threw me off that it said the initial is 1600, right? It did say that, so I don't know. I feel like it's a bit misleading there. C. How long is it required to achieve half the initial radiation level? Half the initial radiation. So we know that initial radiation is what? Well, the question lied, right? It is actually what? 1522, right? I'm going to go by that. I told you that I rushed a little bit, right? So these are textbook questions, and I feel like that is not fair. Not fair. Initial radiation is that. So half, right? Half would be just divided in half. Divided by 2. It's 761.04. So we're going to find, right, how long it takes to get to half of that. So what is this for our variables? Is it our x variable or our y variable? It's our x variable. I determined that way up here. Way up here, I told myself right away, x is radiation and this is time. So we're going to go second trace 1, x is equal to 761.04, and we're going to figure out our y value, which is going to be in years. Okay, so we're going to go ahead and do that. Second trace 1. Did some of you try finding the values of the when you did the homework. Some of the values were super big, like you had to expand your window to like a billion or a trillion to make that work, and it was actually good practice. Years, 25.20 years to get to half of the initial radiation. What is the radiation level that is reached in 100 years? They're giving me what? Time, right? Y2 is equal to 100, second, trace 5. Doesn't it mess with you a little bit that time is your y variable, right? All these years, time is always x, 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 except for logs. Logs kind of twist that on you. And as long as you're careful at the very beginning to tell yourself what's what, it shouldn't really bother you that much. So y2 is equal to 100. I'm going to graph that line. There it is. Second trace 5. Enter, enter, enter. And it's 97.28. So x is 97.28. What units would we be using? You guessed it. MSV. Okay. Is that being used in science at all? Anybody taking science or something where that's, or physics maybe? Okay. E, let's try to fit that in here or somewhere on that piece of paper. If a level of 10 MSV per year is considered safe, how long will it take for the contaminated area to be considered safe? We're going to go second, trace 1. X is going to be 10. And here we go. Second trace 1, 10. And that is Y is 182.72 years. That's why. So we just need to make sure. Can we do the domain and range here? F, domain and range. Let's see if we can figure this out. The domain is my radiation level, correct? What's the lowest radiation according to what we just talked about? What's the lowest where we are like, that's safe now, we don't need to worry about it anymore? It's 10, right? So the lowest would be 10. And what's the highest radiation level according to the actual model? What was it here? We figured it out. 1522.08. I almost want to scratch that 1600 right off of it, but we'll just leave it. And then the range is the change in y, right? So we go all the way down to 0. 0 is actually included, right? Because it touches the x-axis. All the way to the highest time that according to us, right, is 182.72. Considered safe, right? After blank years, right? So that's why that came in there. So the homework is just keep going what comes after this question. And I will post the answer key if I have time. I'm not sure. I will do at least one more as a video if you'd like. I can't promise that. Maybe tomorrow at some point, I might. I will ask to go to the bathroom, right, during the meeting, and I'll be back in like 20 minutes, just like a lot of students do. Right? Where were you? So to be clear, it follows, right? Page 39, page 40, 41. There's an exponential, guys. Exponential, page 42. Right? It keeps going for a while. So I will just post I will post as much of that I already have, and if you want to go beyond that,